Welcome again. In the last class we have seen what happens if we swap the plus minus inputs in an inverting amplifier. We can ask also the same question, what happens if we swap the plus minus inputs in an non-inverting amplifier. Okay, so this is the correct non-inverting amplifier. Now let me draw the wrong circuit, so where I will make this minus and this plus. Okay, so therefore I should also call this Vn and this Vp. So if I connect the op amp in this way wrongly, this is wrong circuit of course, what happens then? Now the analysis will be very much same and similar to the analysis that we did for the previous case, inverting amplifier. I request you, do not watch this video, please do not watch this video, but do the problem on your own. Okay, although I will do it again in this video. I request you not to watch this video. Okay, so once again let us first ask the question. So the question is, given V2, what will be, how much will be VO? Okay, so that's the question. Now what can we say about Vp and Vn? Vn is of course equal to V2, known, but Vp is unknown. So unknowns are Vp, this one, and VO, this one. Output, of course, this is what we want to find out. So there are two unknowns, so we need of course once again two relations, two equations. Now first equation that will come from this part of the circuit, okay, which is the series combination of R2 and R1. This potential is 0, so we can immediately write Vp is equal to VO multiplied by R1 divided by R1 plus R2. Very quickly you can find the current, you can then multiply that current with R1 to get this voltage. Potential divider rule essentially. So this is Vp. Now let me write the same thing in terms of VO, because we will draw VO in the along the y-axis, Vp along the x-axis. So let's write this in terms of VO. This will become Vp multiplied by this R1 plus R2 by R1. This is true. This relationship is same no matter whether we have this plus minus symbols correct or wrong. This is because this is from the external circuit. And the other relation which comes from the op amp, that is the static characteristic. Let's draw that. So we have VO, this is Vp minus Vn, and the characteristic as always is like this. Now the unknowns are Vp, because Vn is known. So Vn is known, so now Vn is equal, so this equal to V2 some value. Okay, now if I want to draw this only in terms of Vp instead of without having Vn, okay, then this curve will shift the origin. Okay, which way will it shift? Towards the left or towards the right? Take an example. So let's take an example that V2 or Vn is equal to say 5 volt. That means now this is equal to Vp minus 5. Okay, so at this point Vp, so at this point therefore we have Vp minus 5 is equal to 0, which means Vp is equal to 5. So in the other curve, therefore, when Vp is equal to 5, this crossover will take place. So at the point where Vp is 5, say if this is 5 volt, okay, if this is 5 volt, or then this is where the crossover will take place. So in general, in place of 5 volt, let me put the value V2 or Vn. Okay, whichever you like. Okay, that's it. So this is one relationship. Now let me draw the other relationship. This is y equal to x times a constant, positive constant. So it will be a straight line passing through the origin with positive slope. So that will be a straight line passing through the origin like this. Okay, so this is relation, call it 1. So this is from relationship 1. Okay, great. So far so good. Okay, this is VO, this is VP. Now what will be the solution? The solution will be either this or this or here. Let me extend. Okay, so I have 3 possible solutions, and once again let me just call them A, B and C. I can justify that B is unstable. Okay, you do the analysis on your own, I request you. So like this, so if you start from this point, move a bit, then you see at this point the op amp would like to have more output, so it will go further towards the right, or it will try to increase the output and it will land here. Similarly, if we go a bit towards the left with a decrease of VO, then at this point op amp will try to reduce its output further, so we will move further down or towards the left and come here. Okay, so point B is unstable. So we will have the solution A or C. If we are at point A, then the output will be minus V supply. So at this point we have VO equal to minus V supply. Here we will have VO equal to plus V supply. So the output will saturate. It will be either negative or positive saturation, and it will depend on whether what was the previous value of output. If I start from the assumption that, you can take the same example that like we did before. Okay, so let's take once again as an example, let's take here R1 equal to 1 kilo, R2 equal to 1 kilo. So this will imply Vp is equal to VO by 2. Okay, 1 1 1, so this is VO by 2. So then Vp is equal to VO by 2. Take this example. So then start with the assumption this is plus 15 volt. Then this will be 7.5 volt, which is greater than Vn. So we will stay at the positive output. If we start with VO equal to say minus 15 volt, then also this will be minus 7.5. So Vp is less than Vn, output will remain at the negative value, no problem. Okay, So that's it. So once again, let me write few more points. So solution is A or B, which means VO is equal to V supply or minus V supply depending on previous value. Okay, and what else can we say? This will not work definitely as an amplifier. Okay, so the relationship for an this is non-invert, originally it was non-inverting amplifier. So the relationship VO equal to 1 plus R2 by R1 multiplied by V 2, this is not true. Okay, because output is going to be constant at the saturation levels. It's not going to change linearly or proportionally with the input. So this is not an amplifier, not an amplifier. Amplifier is supposed to give output proportional to the input. So this is not an amplifier. What else can we say? Can we say something about the virtual sorting? Virtual sorting is not going to work. Okay, virtual sorting is not true. Why? This is not true. Why? Say, so the solution will not be this. This is unstable. So let's consider only C or A. If we are at C, then Vp will be this much positive. Okay, Vp will be this. And what is Vn? Vn is equal to V2. Is this? Vn is equal to V2. So Vn is here, but Vp is here. They are not equal. Similarly, if I am here, once again, Vp will be at this point. Okay, and it will not be same as V2 or Vn. So virtual sorting is not going to work. Now maybe I will show you one more small thing, interesting thing, which is this. Okay, suppose so the question is, what happens, say, if I change the input V2, say if I change it from 5 volt to 1 volt, 10 volt, whatever, what will happen? Okay, so will this green line change? No, because this green line obeys this equation and it doesn't depend on V2. So what will change? This black line will change. Why? Because this black line depends on V2. Because this black line is supposed to cross the x-axis at the point of V2. So if I change V2, this black line will move towards the left or right. I'll show you like this. Okay, so let me copy this black line. Okay, so now if I increase V2, I'm increasing V2. So you can also see how the solution will change. Okay, so if I increase V2, point C is not changing. Neither is point A. Okay, if I decrease V2, the input, point C and point A, they are not changing. The solution will remain same. But now if I increase it a lot, if I bring it like this here, if I bring it here, then you see that now this green line and the black line will intersect only at one point. It will only intersect at this point. If I extend this black line here, then this will intersect here. So then only point A is the only one solution. Point C doesn't exist anymore because in this direction they will not intersect. Similarly, if I bring it down, 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 a lot and a lot like this here, then once again you see this green line, if I extend it, will not intersect with this black line in this direction. It will intersect only on the right side. If I extend it on the right side, it will intersect here at the point C. So once again there will be only one solution. Okay, so let me bring it back. That means we can have either one or three possible solutions. Okay, similarly, actually let me just go a bit back to the previous class where we were talking about what happens if we change plus minus sign for, this was what, inverting amplifier. Okay, so now you can ask once again in this diagram, what will be the solution, or how will the solution change if I change the input V1. So what will change here? Let's see. If I change V1, then this green curve which is given by this equation is going to change because it depends on V1. But this black curve is not going to change. Okay, so if I say increase V1, what will happen? This green curve this will come down because the y-intercept will become further negative. So it will come down, down and down like this. Okay, point B, which is the unstable solution, is changing, but don't bother about that, but that's unstable. Point C is here, still at the saturation level, and now if I bring it down a lot like this, that means if I increase V1 a lot, okay, V1 is really a lot, okay, then there will be only one intersection. Okay, and similarly if I increase it up, once again you will see there is only one possible solution. Think it yourself. It's nice, it's a fun. Thank you.